Okay, so continuing on with number 10 in 2.1, I wanted to show you how we're going to find a tangent line, basically. So what we do, like I said, we use that definition on page 61. Now there's quite a bit of algebra in this, so I will have these notes saved for you, and you can print them out and look at them. I just wanted to highlight a few things. So this definition that you have on page 61 is this, and what it actually does is it's going to find the slope of a secant line, a generic secant line. So but if we look at just the algebra behind this really quickly, I already did a lot of this work. So this f of x sub 1 plus h, the x sub 1 is your x value at the point you're working with. So for this question, our x sub 1 is actually 1. So I went over here and I found what that value is going to be. So that means that I need to find what is my function value at 1 plus h. H is a permanent part of that equation. Don't get rid of it. You're not going to plug anything in for it. H is just h. So we need to find what is f of 1 plus h. So that means plug 1 plus h in for each x. So we have to take 1 plus h and square it, and then minus 4 times 1 plus h. So you go through the algebra. You get that done. You get h squared minus 2h minus 3. So I have plugged that value in right there. And then I went ahead and found my function value at x sub 1, which in this case is my function value at 1, so that means just plug in 1 and you get negative 3. So I plugged that in. Be careful because there is a minus built into this. So it's going to be minus a negative. Okay, so watch your algebra on this. If you mess anything up, it usually is always in the algebra. I see a lot of people fall apart right there. So if we clean this up, we end up with negative 3 plus 3. So all we're left with is h squared minus 2h plus h. And then we can factor out an h. And your goal on this, we want to plug in 0 for h. So you want to basically make your goal is to get rid of that bottom h. So at some point it's going to have to factor, or something's going to happen to cancel it out. In this case, we can factor out an h up top, and then that allows us to reduce our h's. So it reduces that generic formula for the slope of a secant down to h minus 2. Now, h is the distance. If you read through the example there on page 61, h is basically the distance between any 2 points, the x distance, the distance between the x's. When we want a slope at a single point, which is a tangent slope, like I said in the previous video, that means that those 2 points have met at a single point. So one is approaching the other. So at this point, in this problem, we're working with the point 1, negative 3. So and the distance between them is 0. So in order to turn the secant slope that we have here into a tangent slope, we want to let h be 0 because we're letting our 2 points, that distance, which is h, become 0. So if we plug in 0 into h minus 2, which is what I did here, you get negative 2. So that's the slope of the curve at that point. That answers part A for number 10. And then we need to go on and we need to find the equation of a tangent line at a point with that slope. So we're working with the point 1, negative 3, and we have a slope of negative 2. This goes back to basic algebra. You're going to use point slope form. This is something that you want to embed in your memory and don't forget it. So you plug in this is your x sub 1, your y sub 1, and then this is your slope. Reduce that down, and you find that your tangent line is y equals negative 2x minus 1.